Welcome to the 6th in the series of World Cotton Research Conference webinars. And today we're going to be continuing on our theme of excellence in cotton research. And I'm delighted to welcome two world-class cotton scientists who are going to talk about two really topical subjects for us today: sustainability and water. So without further ado, let me introduce our first speaker, Mr. Allan Williams, who is the General Manager for Research and Development at Investment at the Cotton Research and Development Corporation in Australia. Allan has been involved in the cotton industry for pretty much all of his entire life, having grown up on a cotton farm and worked in various industry roles since 1995. Two intersecting themes have dominated Allan's work in cotton: research and sustainability. His initial role involved working with cotton growers to review and prioritize research investments in cotton growing. Allan also led the development of the Australian cotton industry's BMP program, now known as MyBMP. And following 11 years working on BMP, Allan then started working for the global Better Cotton Initiative, again leading the development of the definition of better cotton. This saw him expand his cotton farming perspective to locations including Brazil, West Africa, India, and Pakistan. Since leaving BCI in 2012, Allan has worked for the Australian Cotton Research and Development Corporation, where he is now the General Manager. Allan also chairs the ICAC's expert panel on social, economic, and environmental performance, SEEP. And with that introduction, Allan, the floor is yours.
Thank you very much, Kai. I'll just get the screen sharing to start. And I hope everyone can see that. Good morning, good afternoon, and good evening. Dr. Kranthi kindly left the topic of this talk, the challenges with cotton sustainability, very open for me to interpret. So rather than talk about the specific sustainability issues associated with cotton, which I imagine that most, if not everyone on this call will be very familiar with, I'd like to focus on the challenge of measuring sustainability. How do we measure it, and who measures it? And I think I'll try and show that who measures it will determine how it's measured. Also, in the spirit of doing things differently in the age of online conferences, I'd like to flag this is not going to be a typical research conference talk. I'll be unashamedly bringing a very personal perspective to the issue of measuring sustainability in cotton farming, both as someone who's had a long involvement in the cotton industry and as a landowner. Of course, this is a research conference, so please be assured I will be citing some research findings as well as my personal experiences. My main thesis that I will put to you today, tonight, this evening, is that when it comes to measuring sustainability of cotton farming, there are two parallel data collection or impact systems underway. And today I'd like to explore some of the implications of this with a focus on water that I hope will complement nicely Marcelo's talk following mine. One implication to keep in mind throughout this talk is that both how we measure sustainability of cotton farming and who determines that how will directly influence the key messages that people hear. So as Kai kindly said, I grew up on a cotton farm near Weewar, if you look at the purple arrow, and I still live on a farm near Narrabri, which is only 40 kilometres away from where I grew up. And you can see photos of me standing in both the first crop we ever grew on the farm and the last crop. And I hope you can determine who I am in each of those two photos. One thing I would like to make clear, though, is that while I grew up on a cotton farm, I'm not a cotton farmer. My role at the Cotton Research and Development Corporation is to oversee the investment in research for the benefit of the Australian cotton industry and its broader community. Nevertheless, I have the very good fortune of owning a 350 hectare grazing farm, and the even better fortune of not having to rely on that farm as my main source of income. And I think you'll see why I say that in a minute. So quickly, what are the two parallel data collection and sustainability measurement systems currently underway or being used? The first system is what I call the farm-focused or good agricultural practice system. The ultimate aim is to understand the impacts of farming practice and use that information to support improved farm management. That was very much the intent behind this framework document, jointly published by the International Cotton Advisory Committee and the FAO in 2015. It provides an overview of sustainability themes, including the actual challenges of cotton farming from a sustainability perspective, and importantly, recommends a set of indicators to assess and measure progress on the critical sustainability issues for cotton farming. As I've argued before, systematic adoption of the framework would give rise to a range of potential benefits for the cotton industry. First one is standardizing the indicators by which the performance of the global cotton industry is measured will improve the reliability of the cotton industry, improve the ability of the cotton industry as a global entity to understand, report on, and improve its social, environmental, and economic performance. Secondly, and really importantly, it would allow the cotton industry to properly assess the data being used by the downstream supply chain to measure or assess the performance in their view of cotton, and check that that information is accurate and fairly represents the performance of cotton globally. And I think equally not standardizing the indicators makes it more difficult for the cotton industry to compete against man-made fibers when they play the sustainability card against cotton in regards to their own performance. Importantly, with this farm-focused framework, data collection sustainability measurement system, the primary objective for collecting data is to help the data collector, who could be a farmer, a researcher, an industry body such as CODC, or indeed ICAC or INTA, or a cotton initiative like BCI, Fair Trade, Cotton Made in Africa, Organic, to help them understand what is going on at the farm or systems level. Ultimately, the aim is to better understand and compare the impacts of different farming practices environmentally, socially, and financially, and then identify areas and ways to improve. Importantly, given that need to feed it back to the farm level, the data collected is generally detailed and site-specific. The second system, while also very interested in the impacts of cotton farming, is, however, very supply chain focused. The aim is to help the collector understand the impacts of their entire supply chain, inform procurement policies, meet corporate sustainability goals, or underpin marketing based on environmental labelling and product comparison. These three images show from left to right a comparison of the water used in making different products. In the middle, the contribution of each stage of the manufacture of a pair of jeans to the carbon footprint of that pair of jeans. And the last image on the right of the two t-shirts claims to show how much land in green and how much water in blue is required to produce that t-shirt. All these calculations will be based on life cycle assessment, or LCA for short. LCA is a tool used to assess the environmental impact of a product throughout its life cycle, from the extraction of the raw materials, so including cotton farming, through the processing, transport, manufacturing, making of the garment, sale of that garment, use of the garment by the consumer, and disposal, its ultimate end of life. Complex methodologies are used to assess the environmental impact of a product, including areas such as water scarcity footprint, global warming potential, eutrophication, ecotoxicity, and land use, to name probably the ones most topical or relevant to cotton farming. Given that cotton is still a commodity product by and large, the data is collected at a very different scale to that of the farm-focused good agricultural practices system. It will be based generally on averages for a given region or even country or type of farming system. It can and often relies heavily on proprietary, that is hidden LCA data sets that you cannot see unless you pay a fee, or remotely sensed information such as that acquired by satellite imagery. This second system is characterised by initiatives like the European Union's Product Environmental Footprint Category Rules process, which is seeking to use life cycle assessment to ensure that environmental claims that are made, for example, and especially on a label on a garment, are made using a consistent, robust approach and therefore can be comparable. So if a consumer is looking at two different garments, then any environmental claims have a valid basis for comparison. That is, that they're comparing like for like. These two systems, while focused on the same broad issues of sustainability, are driven by very different needs. Nevertheless, and this is the critical part of my thesis, I think that because there is significant overlap between the two systems on the specific issues of interest, for example, at the farming level, water use, greenhouse gas emissions, for example, and because you can use farm level data to inform an LCA, then there is an implicit assumption that is a relatively straightforward matter to either aggregate data up from the farm level to that supply chain level, and equally that LCA data collected at that very broad level, collected remotely, is somehow useful information for a farmer. In other words, it is assumed that it is relatively straightforward to move data between the two systems to meet their respective needs. So really, the claim is, or the thinking is, it's really just a matter of making sure that each of the systems collects data relating to the same areas of impact. So pesticides, water, greenhouse gas emissions, and that equally we use the same metrics or calculation methods to make sure we're comparing apples and apples and not miles and kilometres. Now, people that have heard me talk about LCA before will know I'm not a big fan. I just want to be clear. My concern is not that they are inherently flawed, but then when it comes to their use in agriculture, they have some serious limitations that need to be recognised, and I don't believe these limitations are being adequately recognised, in particular, given their use as a labelling mechanism. And these need to be recognised to avoid perverse outcomes or unintended consequences. Like all tools, it needs to be used appropriately. While an LCA study can be useful for identifying hotspots in a system or supply chain, they don't have much of a role to play actually helping a farmer improve their environmental performance. I equally have some serious concerns about the implications for an LCA-based labelling system as it would apply to a commodity raw material like cotton. I think it will present some real challenges to both farmers and retailers and brands, given some of the limitations I will discuss in more detail. So I will try and point out some of these challenges in either going from the farm to the supply chain, and more importantly, the limitations of using an LCA to inform farm management decisions and therefore help reduce impact. I guess implicit in my focus on the challenges of translating useful information between these two systems is that better aligning them is indeed worthwhile. And I believe they need to be for a number of reasons. We need to ensure that the limitations of an LCA-based sustainability measurement system are clearly acknowledged, especially given its current and likely continued use to underpin product labels and advertising, i.e. the information from the LCA results is being used to communicate directly with consumers. I don't think we can stop that train. We need to do that because they do not convey the complexity and variability inherent in the natural system that agriculture takes place in. They were designed to identify priority areas for reducing product footprints, not as a tool to underpin communications to consumers. Secondly, they're not comprehensive. They only focus on environmental aspects and say nothing about social aspects. And further, not all environmental aspects are even included. when it comes to textiles. So the environmental impacts associated with microfiber pollution are not scored in any of the current methodologies used to assess the environmental footprint of textiles, be they natural or synthetic. And as I've said, and I will keep stressing, an LCA does little to inform what a farmer should be doing to improve. I think a really key part of this too is that data collection, validation and analysis is time-consuming and expensive. If the benefits of the sustainability framework developed by ICAC and FAO are to be realised, we have to be smart about how we collect and analyse and talk about data. If we have two systems that are not well aligned, we are being inefficient and limiting the impact, the serious money that is being invested to monitor, measure and improve the sustainability of cotton farming across those two systems. We also critically risk confusing consumers with contradictory information. So what I'd like to do now is put some of this in the context of my personal experiences. I'll play you a short video of my farm, and just to be clear, there is no sound with this video, but I hope the pictures are coming through nice and clearly. As many of you may know, most of Australia experienced an extended period of severe drought between 2016 and 2020, and our farm was no exception. These images were taken in January last year. In February last year, we received more rain in 15 days than we did in all of 2019. And of course, you can see the magic that that rainfall has managed to create on our farm. There are a number of implications for what this means for measuring sustainability. The first one is to highlight the limitation in using a point in time. In an LCA, land use impact assessment takes into account things like the erosion potential of the land and the level of organic matter. These will have changed dramatically in the 12 months since that rainfall, so the timing of that data collection will influence fundamentally the outcome of a point-in-time LCA, even though the only change has been the amount of rainfall. If this land was being used to produce an eco-labelled product based on an LCA, which it's not, but at what point of time would it be appropriate to calculate the impact? Before or after? Clearly, if you're wanting to promote the sustainability, you do it after. But would the label have to be changed every year based on annual data, or if there's a significant change in the scores? Even if the change is due to natural variations rather than any change in the management practice, the things actually under the control of the farmer. And what if it is a blended commodity like cotton, where the fibres in a garment could well have come from several different countries, let alone several different farms? So a key point is that measuring sustainability in farming is a long-term game, given the potential influence of seasonal variations and the complexity of interactions. This variation and complexity needs to be monitored and measured over extended time periods to identify trends and the impact of any management intervention intended to improve a particular sustainability metric. And of course, as many of you would know, it's not just water availability that is a fundamental driver of the farming system. There are any number of other variables outside of the control of the farmer that can affect any sustainability metrics and which need to be monitored over extended periods. Other seasonal variations include the temperature ranges, how hot, how cold, the cloud cover, not just rainfall amount, but rainfall intensity and rainfall timing. And these in turn, of course, can affect the insect pressure, the weed pressure, the weed profile, and disease pressures. And these all in turn then impact yield and the level of other crop inputs that might be required to manage that crop. And of course, particularly with soil, there are a whole range of local factors that vary from region to region, between farms, and even within the same farm. Soil type, soil fertility, the nutrient levels, the water holding capacity of that soil, the bulk density, and the slope of the land are all things that are highly variable. So to move away from our farm, but still very local, as an Australian, you might be surprised to learn that it is expected that any presentation to an international audience has to contain at least 2 images of strange animals found only in Australia. So here is the first one. This is a giant pink slug that grows up to 20 centimeters long and is not only found only in Australia, but it's only found in one place in Australia, and that is an area of about 100 hectares at the top of the mountain range near where I live. And I promise that there has not been any photoshopping whatsoever of this picture. It truly is that bright pink in nature. And so what I'd like to do is use this picture of the bright pink slug to exemplify the first of 2 types of magic I'd like to talk about, and that is the magic of nature. So as my video, I hope, showed, the ability of soil, and especially the soil microbes essential to soil health, to recover from extended dry periods is, I think, truly magic, as is the ability of plants to turn carbon dioxide, sunlight, and water into carbon, food, and of course, cotton. Even better, some plants, with the help of bacteria in the soil, can take nitrogen from the air and turn it into the nitrogen that can be used by the plant. Unfortunately, cotton is not such a plant, but that is one of the research challenges I think would be fantastic to crack. But now turning to a very different type of magic, or a second type of magic, which is less magic and more scientific methodology. And returning to my theme about LCAs, an aspect of LCAs that is important to understand is that there could be multiple methods for calculating an impact, and that the choice of method can significantly affect the calculation of how much water is said to be used or how much carbon is said to be emitted in producing something. Here is a real-world example from the Australian dairy industry relating to an LCA-based water scarcity footprint assessment of how much water is required to produce a litre of milk. Data was collected from 75 dairy farms from 3 regions across Australia. And that data was used to calculate the water scarcity footprint using 3 different models. So each model represents the results from one of those models, with the average of all 75 farms highlighted in that blue strip across the middle of each bottle. The range of results for each model is on the right-hand side, above and below the bars, and you can see the ranges for those models as well as the average for those models. So as you can see, there is a greater than 300 times difference between the model with the lowest average and the one with the highest average, from a low of 18 to a high of over 6,600, despite the same 75 farms being analysed by each model. So clearly, from a consumer perspective, it would send a fundamentally different message if you said a litre of milk takes 18 litres to produce, compared to it taking 6,600 litres of water. But these figures are all based on legitimate LCA methodologies for assessing the impact of water use. A lot of the variation in the information regarding how much water is required to grow cotton can be attributed, I suspect, to differences in the methodology used, and obviously an individual's perspective might influence their choice of methodology, dare I say it. So another aspect of LCA to emphasize is that, like all areas of science, there are different approaches. So the 3 models here all doing the same thing. And equally, the methodologies themselves underpinning the calculation of an impact evolve. They are not static. They are subject to refinement and even fundamental change from one method to another method. And you can see the potential impact in this example of changing method. And so quickly, the emissions factor associated with use of nitrogen, which effectively translates the amount of nitrogen used into the equivalent carbon dioxide emissions, has changed from 310 down to 298 and may well change again. This can make it difficult to compare studies if it is not clear what factor has been used to convert nitrogen use to the equivalent in carbon dioxide emissions. Is a change in a figure due to an improvement or simply a change in methodology? In my experience, LCA studies looking at cotton are very poorly referenced, making it difficult to know what data, what assumptions, and what factors have been used to come up with that single number. They can also show huge variations. I have seen studies with a 10-fold difference in the estimated carbon emissions per bale of cotton produced in Australia. Rather than having to factor in often technical changes to methodology that make understanding change over time even more difficult, it would be better for the cotton industry to have its own agreed set of indicators that are as straightforward as possible and don't rely on the black box of an LCA to produce. One of the fundamental gaps between the two systems is that of scale and logistics. As we know, there are tens of millions of cotton farmers, and given that cotton is a commodity, it's currently impractical to expect to have specific impact information from every region, let alone each farm and piece of cotton. Yet that is what the supply chain, I think, is aiming for. In the meantime, it's understandable that they use remotely sensed data, such as that acquired from satellites, to often inform sustainability analysis. And so it's important to understand some of the risks associated with relying on this type of remotely sensed data. So the first image on this slide, the one on the left, is a picture of the creek that runs through my property with some water flying after all that rain in February last year. I've lived there for nearly 30 years, and that creek probably flows for about 10% of the time, simply because we don't get enough rain in the mountains for it to flow all the time. However, that hasn't stopped a government agency determining that there are fish apparently living in the creek and that they are endangered, which is hardly surprising if there's rarely any water in the creek. I can only assume that someone has decided that there's a permanent creek by looking at a blue line on a map and assuming that it always has water. Now, the middle photo is of a kangaroo that is eating our lawn during the middle of the drought. Actually has nothing to do with this presentation. I just need to get the second photo of an Australian animal into the presentation. So I've now achieved my quota of Australian wildlife. I can move on to the last image, and that is of a bed. So why a bed? Well, according to a famous mapping service, our farm is actually a hotel. And you can leave a review for what the accommodation is like at our apparent hotel on our farm. Now, luckily, I'm still waiting for our first review, and I'm very much hoping we don't get a first review for obvious reasons, given it's only my wife and I that live there. Now, I guess this can be seen as amusing and unsurprising. It goes without saying that ground truthing of remotely sensed satellite data is essential. So the point I'd like to make is a bit more fundamental. This type of information, if presented, and especially if presented in the context of expecting someone to change what they're doing on their farm as a result, which these sustainability programs often do, can actually be counterproductive. Landowners with local knowledge will not only rightly dismiss the information, but it will also make them skeptical about any program seeking to bring about change, no matter how important or well-intentioned that program it is. So an important part of using an industry set of sustainability indicators is that they will be very farm-focused, and that information can be used to directly inform what can be done to improve. The importance of local context will be much more hardwired into the system. Knowing what your water footprint is, irrespective of how it is calculated, really doesn't tell you much about how to improve it. You need to identify the specific components of the irrigation system where there might be opportunities to save water, and then you need to investigate what technology options are available that suit your farming system, which will be very individual to you. To determine the best options for you, you need to know your soil type, your water source, how far your farm is from that water source, the quality of that water, the labour requirements for that irrigation system, what rotation crops you're planning to grow, and what access to capital or money do you have to install a particular type of irrigation system. LCA tells you nothing about any of those aspects you need to know. As already noted, a challenge with LCA is that they very much focus on a single number and don't reflect the complexity and variability of farming systems. As this chart shows, there is not a single number for what the optimum nitrogen use efficiency figure is. Basically, anything within that white zone can be said to be optimum nitrogen use efficiency. And of course, nitrogen is one of the key drivers of the carbon footprint of cotton. So your nitrogen use efficiency or nitrogen use will very much determine what your carbon footprint is. But this level of nuance, where there's a range of optimums, is simply not amenable to being explained on a label, especially when as well as the carbon footprint, the supply chain could be interested in half a dozen other impact categories. So the label is supposed to talk about carbon, about the water, about the ecotoxicity, about the land use, and a range of other factors. And further, still on water use and LCA, as well as the different methodologies used to calculate water footprints, another important aspect to be aware of is that when the LCA methodologies for assessing water impact distinguish between green water or rainfall and blue water or irrigation. And so that slides are of my farm showing some before and after photos of the effect of rainfall. Some nice green water fell on our farm. But basically in an LCA, green water or an in-crop rain is not included in the calculation of water impact. So a rain-fed crop will basically have a 0 score for water scarcity. So if a claim is being made or a comparison is being made around water saving, it is very much worth checking whether there's an actual saving that's been brought about by improved management practices, or has there simply been a switch from an irrigated to a rain-fed production system, i.e. has there been some methodological magic played rather than some improvement in farming practice. And of course, if it's the latter, if it's just methodology, then there's been no change or improvement at the field level. And I think this inclusion of blue or irrigation water, but not green water or rainfall, seems to me like an implicit bias against irrigation in calculating water footprints, especially if the information is used to promote that a product has a reduced water footprint. After all plants need water to grow. Now, I recognise I may be a bit biased the other way, having grown up on an irrigated cotton farm, and I also acknowledge the importance of ensuring that water is shared equitably amongst the competing uses. Nevertheless, it's important to recognise that there are significant benefits of irrigation, such as higher yields, improved production stability, and generally fibre quality that is both higher and more consistent, all of which benefit both the farmer and the supply chain. None of these aspects are recognised in any LCA-based water footprint assessment. So what does this all mean? Given that data collection is expensive, there's a need to better understand how the two systems, one farm-focused and one supply chain-focused, can be better aligned to minimise expense and maximise value to farmer. That includes simplifying, not complicating, how we measure sustainability. And I would argue LCA complicates how we measure sustainability. We need to ensure, secondly, that the focus is on measuring sustainability over the long term, rather than focusing on a point in time. As a complex, natural system, farming data will be highly variable over the short term, and longer term data sets are vital. We need to track change over periods of time that will allow us to properly understand the impacts of changes in management, as opposed to the influence of seasonal variations. Critically, I think the cotton industry needs to take more control over the narrative about the sustainability of cotton. And I appreciate that's easier said than done. What this means, though, is moving away from a point-in-time LCA product marketing-based approach. And I guess we also need to appreciate when we're looking at claims that while nature is indeed magical, there are limits to that magic, and not all types of magic are natural in origin. There is also methodological magic and marketing magic. Having simple, clear indicators will help us better understand what type of magic might be behind improvements. Of course, systematic, robust data collection is difficult, especially given the number of smallholder farmers that grow cotton. So this is a great opportunity to highlight an ICL funded project that includes ICAC as a steering committee member. It is building on that 2015 ICAC FAO framework that I outlined at the start of this presentation, and they're using that as a starting point to develop what they call the Delta framework, Delta being Greek for change. One of the things they're looking to do is reduce the 65 indicators detailed in that 2015 report to a core set of 15 indicators, which is one of the key pieces of feedback we received about that report. So it's being led by the Better Cotton Initiative, but it does involve all the other sustainability initiatives at this stage. And it's focusing on producing a clear, consistent way to measure and report the progress of farms participating in those individual sustainable commodity certification schemes. Crucially, I think it's an opportunity to bridge the gap between the two data collection systems. While absolutely focused on using data to help farmers improve how they farm, it is also investigating how the data can be used to support companies communicate sustainability information to their customers. Further, it is also looking at how the data can be used by governments as well as NGOs and companies to quantify and communicate their progress towards the United Nations Sustainable Development Goals. So it is clearly very ambitious. I'll be the first to admit that. But I guess this is the alternative. If we cannot do a better job of improving how, as an industry, we report on the sustainability of cotton farming, then we will increasingly be at the mercy of this type of comparative advertising. So with that, I would like to thank very much the ICAC for the opportunity to give my presentation, and I will hand the floor back to you, Kai. Thank you.
Well, thank you, Alan, for a really interesting presentation, and one that is extremely topical and will be extremely topical later this year, because the governments at our standing committee meeting have said that the World Cafe, the topic of the World Cafe meeting at the plenary meeting this year will be on sustainability. And also the private sector advisory panel have put forward that they want to talk about labelling. So everything that you've covered today, I hope will be brought up in those two forums later on this year. So we have a couple of questions that have just come in. If you have any questions for Alan, please put them in the Q&A box. So the first one is from Venu. Well, in fact, both are from Venu, but I'll start with the first question, which is how to address the issue of scale in sustainability analysis. At farm level, deepening a well by a resource-poor farmer would improve farm profit by improving water supply and make the farm more sustainable, at least in the short run. But if many farmers deepen their wells, groundwater at community level would go down, making the system less sustainable. So he's making that comment. Have you got any comment on that? I think you're backing him up with what you said in your presentation there.
No, look, I would agree. There's always that balance between the individual and the community when it comes to a shared resource like water. There are, I think, processes and systems that exist around water specifically for how you try and come up with a community-based approach to managing water. So I guess that's, if there's no regulation of how water is allocated in a jurisdiction, then I guess you need to work out how you address it at the community level rather than it being every person for themselves. Otherwise, I agree, it ends up being not sustainable.
And his question, his next point, which is a question, is how to internalize the externalities while calculating sustainability. So a farm adopting IPM would positively influence the neighboring farms too. How do you add value to such positive externalities?
We in Australia, all I can speak about in Australia is we have put in or worked on area-wide management of both weeds and insect pests to good effect, particularly with the insect pests. The weeds is slightly more challenging and a bit newer as part of our investigations. But I guess if everyone is doing it, then everyone is equally sharing in the benefits on their own farm, as well as contributing to the benefits to everyone else. So there's no, I guess, inequity between your contribution and the benefit if it's done at that regional scale. And if it's done at that regional scale, it's more effective anyway. So I guess that's the approach to take rather than trying to separate internal and external benefits between individual neighbouring farms.
Okay, thank you. Keshav, can you see any other questions? I'm looking in both boxes now.
I'd love Keshav's view on those questions. The latter one.
Yeah, thank you, Allan. Thanks a lot. It was a wonderful presentation. Thank you so much.
Okay, we don't seem to have any other questions. Are there any other questions?
Okay, not that I can see.
No, it doesn't look like any are coming in. Well, if you do have some, if you think of some questions, please email them to us or put them in the chat, and we can get them to Allan later on, and he can answer those separately. So thank you, Allan, once again. As I said, it is actually a really interesting presentation and really topical, and the debate will continue this year, which is really good. So we look forward to further contributions from you over the course of the year. So our next speaker is Dr. Marcelo Peytas. Now, Marcelo is the director of INTA, which is the National Institute of Agricultural Research in Santa Fe, Argentina, where he's a researcher and project leader of the cotton team with a focus on crop physiology and agronomy, biotechnology, and genetic improvement. Marcelo graduated as an agricultural engineer at the National Northeast University at Corrientes, Argentina, and he obtained his PhD at the University of Queensland, Australia, in cotton physiology and agronomy. So it is a truly Australian day today, by the look of it. He's a member of APPA, which is the Association for the Promotion of Cotton Production, which is an association of all the representatives of the cotton chain in Santa Fe in Argentina. And he's also the coordinator of the academic and technical agreements between INTA and other national and international organizations, mainly in South America. Like Allan, he's a member of the SEEP, our Social, Environmental and Economic Performance Panel, and his main interest is to link and promote research and development together with the cotton industry through public and private interaction for sustainable production. So with that, Marcelo, the floor is yours.
Okay, thank you very much, Kai, for the presentation. Good morning, good evening, good afternoon to everybody. Let me try to share the presentation. Is it okay? Yeah. Perfect. It is a real pleasure to be part of these cotton webinars, you know, at the World Cotton Research Conference 7. As also Allan mentioned, Dr. Keshav Kranti left me the topic of his talk is is cotton a water-guzzling crop? Very open for me to interpret it and to think about the answer. So, which is a complex one, actually. First of all, I would like to mention that we are a team working in cotton for over a decade in Argentina at the research station of Reconquista in the north of Santa Fe. As you can see, it is a young crew of enthusiastic scientists, researchers, extensionists, linked to many other working people on the crop from other organizations. We have the commitment for sustainability cotton production, and of course, from the territorial demand. The public and the private sectors are involved, as well as the scientific community of other countries, mainly in South America. So where is Reconquista? For all those that doesn't know, where is this place in the world? It's in the north part of Argentina, next to the Paraná River. And the other picture is the station. We are a bit like 20 kilometers from the main city, which is called Reconquista. As you can see, it's a really greeny, beautiful, wet area. And as soon as we start going to the west part of the province, everything starts to get dry. So as a team, we are interested also in other aspects like social innovation, women in cotton, indigenous cooperativism, sustainability in terms of technologies related to climate change, agroecology, genetic improvement. We keep doing mechanization, which is one of the key important things that we've been developing in the last few years. Products at origin, traceability, and others. So what we will be talking today is, as an overview, first, we will discuss 4 aspects, as mentioned on the slides. First is the water and the cotton worldwide, related to myths, facts, and misinformation. The second is related to how cotton deals with water availability, how cotton grows and develops, and the basic. And the third one is related to what are the main limitations for cotton production and physiological processes involved. And the last one, what we can do to overtake water stress from the agronomical point of view or management point of view. So let's start. When we talk about cotton and water worldwide, the information available is massive. However, there are many positions related to water use and impacts. The reason of having reliable database makes our analysis and position stronger, whether it is a myth, a fact, or a misinformation when we talk about cotton and water. Here are some examples of how media express different positions related to water. For example, nature being affected because of water, competition with other cash crops, reasons of not being sustainable, water consumption of cotton, water for people or to feed crops, and many others. As a cotton community that we are here, we should think which actions we are developing to inform, to adopt, to include within the community about cotton. And I know that the treatment for each country will be different. So how we can keep working together with the media and to improve some national public policies. We all know that water is definitely essential for life and has to be always in the agenda for sustainability. It is not only cotton production, it is the whole farming concept that has to be understood by the community and back. And this is, I think, the biggest challenge. I will tell you a little story. I introduced, she's Miss Rose. As we say in Spanish, Doña Rosa. She owns a small grocery shop nearby. When she knew I was starting working for cotton more than 15 years ago, she expressed me, oh, cotton uses too much water and makes a non-sustainable farming. She was originally from a farm. So the question is, how many Doña Rosas we may know? Let's see if we can answer to her comment about water and cotton. The third open session of the 2016 ACAC plenary meeting referred to reducing the water footprint of cotton. The panel of specialists summarized that cotton has been criticized for the intensive use of water and its production and processing, even though that 40% of the world cotton area is grown under rain-fed conditions, and the volume of water used in cotton production is only half that of rice or sugarcane as examples. If we compare, when we compare between irrigated crops, wheat, rice, and maize are the main ones with 15, 13, and 10% respectively, while cotton consumes only 3% of irrigation water worldwide. Many other sources refers that cotton gets 1.5% of global irrigation water use in agriculture. The question is, how accurate is this information from one season to the next one. The environmental variability between seasons is key to understand the dynamics of crops and the irrigation and quantify water use, of course. The distribution of cotton worldwide varies among climatic regions, of course. The xerotrophic adaptations confers a unique characteristic on water relations of the crop that is unusual, but is not unique among field crops. In addition, in many countries, cotton farms are located in the most extreme and limited environment compared to other crops. And that is, for example, happened in Argentina and many other places. Irrigated cotton extends, as we can see in the map, from Spain to the west of Pakistan, to south of East India, to northeast of China, including all the countries bordering the Mediterranean Sea. Also along to the Central Asian countries and west of North and South America. On the other hand, rain-fed cotton regions include Central America, South America, and south of the Sahara. Okay, so between these two extremes, we also have cotton, which is produced with supplementary irrigation, mainly in semi-arid and humid regions, like in Australia and some regions of North America. National cotton yield amongst countries is associated with a percentage of irrigation, but not only attributed to water, but it's also the technology applied in terms of seed, management program, irrigation systems, and others. When we plus cotton growing environment, plus water relation, plus interseasonal variations, we can see that are key aspects to understand the performance and yield of the crop in relation to water use efficiency. From official data from ACAC, we can see in the graph how many liters of irrigation water we need to produce 1 kilogram of lint. As average, 1,214 liters to produce 1 kilogram of lint worldwide. But if you search on the web, you may find data that refers from 7,000 to 29,000 liters of water to produce 1 kilogram of lint. This shows again the importance of having a reliable data set of statistics around the world, which is definitely the way to discuss all these type of issues. Also from the ACAC database, the graph shows the percentage of rain-fed area around the world reaching about 55% of the total area. Probably this situation may strongly change year to year. I insist in that concept, depending on the growing environmental conditions and rainfall occurrence. In some cases, supplementary irrigation is needed. This is also shows how challenging it is to produce cotton depending on rainfalls, sometimes erratic, as happened lately in many regions around the world. We will cover later some actions that we may need to overtake when we have water deficit during critical period of the crop, which may influence final yield and quality. Let's jump into the next step of analysis. How cotton deal with water availability, how cotton grows and develops. There are three fundamental keys to talk about water in cotton. The first one, we all know, it's the xerophytic background, which is referred to the wild ancestors of cotton. This was very well explained in the previous seminar in February with the evolution of cotton germplasm around the world. The second aspect to consider to understand water relation is development and basic patterns. And this is basically refers to the capability of cotton of develop of getting to know the patterns of regular production on the main stems, on lateral fruiting branches, fruiting site, abortions, fruit development, fiber development, which are all key different processes related to development. The third is related to growth physiological processes in response to water. This aspect is fundamental to understand when we talk about cotton plant and how varying stages and amount of water availability can affect physiological aspects of the crop. The concept of sensibility to water stress, let's say we have a scenario of drought or waterlogging or different intermediate scenarios, is basically related to in which stage of the crop we are talking, what is the intensity and duration of this water stress, and definitely the definition of water stress includes plant water content and soil water moisture. Cotton is different from most other extensive crops that normally are used as rotation practice within the farm. Cotton is a perennial plant that grows as an indeterminate pattern, which the control of the plant growth is an intrinsic physiological problem. The increase of fruit retention on the plant is the best plant growth regulator for controlling plant growth. As the plant accumulates fruit load, the vegetative growth slows and finally ceases. An appropriate balance between vegetative and fruiting development is essential. As ball load increases, terminal growth and the production of new nodes slow and then cease. This general concept is really important to consider when we are doing cotton management. The other important point to understand is the target growth and development curves. This curve shows the accumulation of vegetative dry matter and the partitioning to reproductive organs. About 70% of the ball weight is accumulated after the termination of the vegetative period. Any limiting situation that happened during this period will be negative to cotton yield and quality. So that's why we need to focus on this critical period in terms of agronomical management, but we will come back to this one. So cotton is a smart plant. We all know about that. Due to its necessary 2.25 times to produce much energy, to produce oil rather than cellulose or fiber. But it's really important at the moment that we're establishing the crop to take care what is necessary to be successful. The first, we all know that is the population of plants per meter. The second is the number of balls retained per plant, and this is basically related to squares, flowers, and balls retention. And the third one is increase the fiber weight per seed, which will give some yield stability at the end. So once we know this and when this happens, we can talk about critical stages. Let's see what happened with this type of typical graph about water and crop stages. The cotton plant undergoes a series of stages during the development from dormant seed to mature fiber. These stages are distinct, but they are also overlapped in some situations. When the water supply is plentiful, phenological development continues for longer, resulting in a larger plant and higher yields. When the supply is limited, the opposite happens. The key adaptation of the cotton plant is that when water supply starts to become limited, the plant responds and stops further morphological development and focus on the maturation of the fruit already set. During the vegetative stage, the consumption of water is smaller compared with the mid and later stages. The evapotranspiration rate, the plant available water, and the soil water content, again, are key measurements to do monitoring and prediction of cotton performance. We will develop the effect of water on the plant, but for now, we can say that water at least keep leaves cool. Drought, when we want to define drought, basically it's defined by low soil water availability and high evapotranspiration demand. We have been carrying out experiments to understand the effect of water stress on cotton under field conditions, using plastics between rows and rain shelters to make sure the limiting factor was created. Soil water meter was used, as well as other equipment, to characterize physiological processes such as photosynthesis, stomatoconductance, water potentials on plant and others. We consider water stress when the soil is less than 50% of field capacity. Cotton responds to stress varying on the stage of the growth, the degree of the stress, and the length of the time imposed. Let's see, this is an interesting graph showing some results, some information related. Even though that cotton has a xerophytic background, to prevent yield reductions, cotton crops generally require enough water to allow about 700 millimeters of evapotranspiration, which is considered transpiration plus soil evaporation. But the lack of water in certain stages can be critical. For example, when the water stress was imposed during the vegetative stage, the following happened. The plant population was reduced, the vegetative dry matter was reduced, and the physiological process involved in cell expansion and division was affected. Having a reduction of yield by an imbalance between sink and source at the very beginning, which is the vegetative stage, has an impact, a smaller impact than the other stages on the final yield. For example, 6 kilograms of fiber reduction per day of stress. So when this happened during the vegetative stage, we still have time, probably, for compensation later on. When the water was imposed during flowering stage, basically the fruiting site reduction was one of the main effects. The flowers bud abortion was also affected. The yield reduction, it was also highly affected, producing in some cases up to 15 kilograms of fiber reduction per day of stress. And of course, that fiber quality was affected. At this stage, when we talk about compensation, if it happened, the water stress during early flowering or early stages of the flowering process, the compensation will happen. If not, the compensation may not happen. And what is the way of having compensation is basically with a new position on the lateral positions and on the vertical position. So if we look at the last part of the figure, which is when we apply water stress during maturity, we can see that the ball size reduction was affected. This makes an earlier maturity, and the fiber quality was also affected. We are also conducting some traditional genetic improvement programs, genetic selection by molecular markers and genetic related to mutagenesis for abiotic stress and higher gene turnout. But I want to be focused here and to make sure the message that is well documented that modern genotypes may show a better water use efficiency due to different factors, for example, shorter period to maturity than the older genotypes, which were longer. We're talking about the 80s or the 70s, for example. So there is an evolution in terms of selection of genotypes related to water use efficiency. The other extreme, we were talking about drought, but the other extreme is waterlogging. Waterlogging is considered as an excessive soil water availability during certain time. And for this, we run field experiments with field conditions and simulating waterlogging using a non-drainage experiment. The crop was studied to understand the effect on yield and quality. The cottons also respond to stress varies on the stage of growth, depending on in which stage happen the waterlogging stress, the degree of stress, and the length of the time imposed. The reduction of 16 to 19% of fiber with waterlogging during flowering was imposed during flowering for narrow rows versus conventional respectively. Argentina is mainly a producer of cotton with the narrow row system. And that is why we usually are comparing the traditional 1 meter row with the narrow row system that we have here in Argentina. As an example, I would like to share with you a diagram model when we want to explain which type of process are involved in a certain situation. In this case, this diagram is showing us, for example, when we have an extra irrigation at pre-flowering. Because usually the normal is that at the beginning of the crop is not demanding too much water. But let's say if we irrigate early, that will generate an effect on plant available water, which definitely will affect leaf growth, leaf area index, and light interception. All this package happen before pre-flowering. This will generate new assimilate production with an increase in total dry matter by the time we are in flowering that will generate a mobilization of stored assimilate, increase fruit retention, fruit production, fruit growth, and final seed cotton yield. So basically, as we can see in this diagram, we can think for different situations in terms of when we are exposing the crop for different water stresses in different stages. Considering a gradient of water available, we may understand that we can go from an excess moisture in soil, which will generate a rank growth. As soon as we start moving from optimal irrigation or optimal soil water to a severe moisture stress, different processes will happen. For example, the first process affected is leaf expansion, as we saw before. Then we will have limiting fruit inside and fiber length. This will be affected also by the carbohydrate production, which photosynthesis will decrease, affecting bore retention, fiber characteristic, and finally will be affected the root growth and function. This is important to focus that the root of cotton is definitely unique and has some special characteristic when we are talking about drought, because of the capability to explore a big part of the soil profile. So when we want to compare the sequence of the processes and compare with the sensibility to a water stress, we can say that a gradient of water available, we may understand that there are different processes related. For example, The first related to sensibility is starting with in a cellular level. For example, tomato resistance, mesophyll resistance, cell expansion. These are the first processes which are affected when we have a water stress. And then it's following by a growth rate, let's say of a leaf or a photosynthetic rate, and then will be affected in a canopy system, photosynthesis, leaf area index, and light interception, and finally the seed cotton yield. This graph also trying to show the importance of getting to know what processes are involved for each situation and each response. As soon as the available soil water moisture starts to decrease, the leaf expansion is the first affected, and then photosynthesis. The leaf expansion will limit the zinc and source assimilate relations and negatively affect the fruit retention. As soon as we decrease the leaf expansion, we will definitely have less assimilate to maintain more flowers and fruit towards the yield, the final yield. So what happened when we compare this graph, for example, looking at leaf potential and in two processes, photosynthesis and translocation, when the plant suffers a period of water deficit, the leaf water potential will also be affected with reductions in photosynthesis, and later on, if the stress continues, the translocation of assimilate. It's important to mention that the inter-seasons results are important to understand variability in terms of evapotranspiration rate and rainfall. In this figure, we can see years with high or higher evaporative demand, like 2006, 2008, that shows a significant decrease in terms of yield when water soil deficit was increased. This is why each year has its own water management strategy, and this is why the statistics in terms of water worldwide may change radically from one year to the next one. So what can we do to overtake water stress? We can propose different actions, but for example, we can propose and evaluate agronomical practices for each situation. One of the actions is the crop rotation and cover crops. In Argentina, in this part of the country, north of Santa Fe, we are using 2 crops per year, or 3 crops per year, 3 crops every 2 years, sorry. So for us, the crop rotation is essential. That's why the cycle of the crop is short compared to other countries. The second action is zero tillage. Zero tillage, it is definitely an action to protect our soil, to cover our soil, and to lose less water by evaporation. The third action would be fertilization at sowing and pre-flowering. This action may help us to overtake a later water stress. If we have enough assimilate source at the beginning of the cycle, pre-flowering, we may overtake later water stress. The number 4 is the crop configuration. The crop configuration, for instance, for us, is related to narrow row system, for example, that for us is very popular. The number 5 is related to sowing date adapted. When we're talking about sowing date, it's basically because we want to make sure that the time of the critical stages have the best environmental conditions in terms of light, in terms of temperature, in terms of water. So sometimes we are looking sowing date in that way. Number 6, crop regulators. We know that we need a balance between vegetative and reproductive biomass to make sure that we have a better water use efficiency. Number 7 is integrated pest management. We need healthy crops, of course. And the number 8 is integrated fiber management, which is not only when we are harvesting the fiber, it's only also when we go up to the end of the processing process. The other aspect is soil health management, drainage systems, or irrigation systems. We all know that irrigation system has been developed, has been evolutionated a lot around the world. Drip irrigation, sprinklers, furrow irrigation, and for each situation, definitely it's necessary keep on working and doing research to make sure what are the best option for management. Another is further research with integration of different factors together for cotton and other crops within the rotation for each region of production. And the last one would be the strength of regional genetic improvement programs to obtain varieties well adapted to limiting conditions. In this case, focus on water use efficiency, looking on the biomass distribution, on the architecture. What are other actions we can be doing, to overtake the limited water growing conditions? We definitely have to keep on doing research on cotton physiology for each production region and the environmental conditions. We need to keep on training for farmers and technicians and the cotton chain related to production and the limiting conditions and networking. It is really important when we talk about the environment, the climate change, and the water availability to have meteorological information available. The historically and daily basis data is very important. So it's good to invest in meteorological stations to get proper and online information related to weather in a regional scale. It's also important the use, as Allan also mentioned during his presentation, the use of indicators for water print on the whole chain, the cotton chain, for sustainable production. I do believe that the Delta project will help with indicators of sustainability and will help to study this process. The use of indicators is important for any type of development that we want to do, looking the social aspect, the environmental aspect, and the productivity. So, what we should answer to Miss Rose or Doña Rosa to finish the lecture? We can tell her that the modern varieties may tend to use more water use efficiency than the old ones. We can tell her also that the other crops may use a bigger amount of water from irrigation worldwide, that outstanding advances in research around the world to understand water relations and efficiencies, and it's keep on going, that there are more and more technology available for a better water use within and outside the farm in another bigger scale. We can tell her also that there are some sustainable cotton programs and indicators, which is key information available, and training is also available to make sure that we are running or we're working on the right way with information. Well, you may also answer if cotton is a water-guzzling crop. Thanks for your attention.
Thank you, Marcelo, for a very interesting presentation. And I would also like to point Madame Rosa to the Truth About Cotton campaign that ICAC has initiated last year, which talks about exactly these subjects. And it's really important to get the facts out there. It's something that we haven't done for many years, but we need to counteract the misinformation around water usage in cotton. We have some questions, so I'm going to start with, I think this one's just a clarification from Eleni Saliki. Is the kilograms of fiber reduction per day, is that per hectare?
Yes, yes.
Okay, so then the next one is from Venkatesh Raichur. What is the role of the cotton root system in order to perform better under drought conditions? How important is the root compared to the above ground plant system?
That is a really interesting question when we talk about physiology and we talk about agronomy. It's really important because it's our first contact with nature after the seed starts to germinate, no? What happens sometimes is that you may have some soil profile limitations. When you have that limitation, let's say like a VT, which is a compacted area, and the root can explore enough to the depth, that can be a problem, a limitation. So there's some management of using some mechanical procedures that can make sure that the crop has the power to go deeper. But if you have like a deep enough soil, definitely the root systems is essential at the stage of water stress. We all know that the root develop and grow in the whole first part of the period up to cutout. So if you don't have excessive water available at the beginning, the root will suffer a little bit, but will try to find a deeper and better in the depths, no? So that's why there is some controversies. Why do we need to irrigate a lot at the beginning, or we should make a little deficit to make sure that the root generate a kind of adaptation for later processes? So it definitely, to answer the question, a root is very, very important to water stress and adaptation.
Thank you. The next question is from Sybil, and I hope I pronounced this correctly, Borgignat. Would you say that there's a huge difference regarding the water footprint between cotton grown with and without pesticides?
That is also another interesting question. I think it's related to the previous presentation as well. What I can say is that when we are talking about cotton sustainability, and we have a healthy crop, healthy in terms of nutrients, in terms of water, definitely that the balance, if we look at in terms of agroecology point of view, the crop is healthier. So we may use less pesticides or being following and monitoring the crop in a different way. I can mention, which is true, that when we compare, for example, BT with non-BT with the same genetic background, the BT may be able to have a better water use efficiency because the non-BT may have some damages in terms of insect pests. And this damage, then the cotton may recover and compensate later on. So your cotton cycle will be extended and longer. So I think that to answer that question, we definitely have to consider whether we want to have a healthy crop, we have a healthy plant or not, basically.
Okay, thank you. So the next one from Nitin Chowdhury. Which crop stage is most critical for cotton in context with water stress for Indian conditions?
For Indian conditions, I may, do you mean the competition between crops? What is the question again?
He says, which crop stage is most critical for cotton in context with water stress for Indian conditions?
Oh, well, that is an interesting question because I have to know exactly in which region of India, because the water, the period of stress, which is related to, which is our critical stage around flowering, you know, the 10 days before, 10 days after, that is our critical stage. So if I will plant cotton in a place, I have to make sure that this window of a critical period has water enough. So I may advise, or I may answer this question, telling him or her that we need to have a meteorological available information to make sure where we will put the window of a critical stage, and to make sure that the critical stage has to have radiation, has to have water enough, good temperatures. So basically that is what we can capture from the environment.
Okay, thank you. One here from Dr. Sabesh. Is there any direct relationship with water stress and fiber quality and fiber traits?
Absolutely. When we talk about fiber quality, we're talking about growth and development. So when we look at how the plant growth and development, we are talking about elongation, we are talking about division, cellular division. The same situation happens when we impose water stress on quality, fiber quality. For example, when the fiber starts to develop at the beginning, after flowering, the first stages has to have enough water, because that can affect the elongation of the fiber. We can end up with a short fiber. It can affect later on the micronerve, which is the accumulation of assimilate within the fiber. So it's the same concept. The fiber grow and develop with the similar principles of a plant. So if we have some limitation for the plant, we will have directly some limitation for the fiber development and growth.
Thank you. Okay, one here from Dr. Upenda Mahesh. For the best retention of bulbs and best plant growth, what are the PGR levels that need to be maintained in the crop?
Can you say it again, please?
I'm trying to just work it out exactly, but it's for the best retention of bulbs and best plant growth, what are the PGRs levels maintained in the crop?
Yeah, that is an interesting question. I think that that is key for all the agronomists around the world. The use of the growth regulators around the world is key, even when we are talking about irrigated or rain-fed conditions. For the question itself, I would try to understand first what type of conditions do they have. If it is like a humid place where the growth and development of the root would be bigger and having the capacity of getting more and more water, then I have to be stronger to the use of plant growth regulators. The plant growth regulators that can be applied by different doses and different moments have to be adapted to the conditions, the local conditions again. If we have a huge amount of resources from the environment, that plant definitely has to be covered by a plant growth regulators. When we have extreme conditions, let's say a water stress, we can go so strong with plant growth regulators. So talking about doses, it definitely has to be adapted and also fragmented during the crop growth, starting at squaring up to flowering.
Thank you. There's one from an anonymous attendee. We always get one every meeting. I don't know why they have to be anonymous, but anyway, what strategies are being considered to better manage the soil physical environment and help overcome water stresses, in addition to zero tillage?
Okay, that is an interesting question. We have a team, a group of researchers here working in physical improvement of soil. What they've been doing basically is crop rotations, cover crops. We are also talking about crops that are essential within the crop, the rotation, but is not part of the cash crops, you know. We are adding within the rotation. It's important within the rotation to consider different type of crops with different root systems, also to cover the soil profile. And on the other hand, if we are not, because not all the farmers are using zero tillage here, we have about 50% of farmers using zero tillage. The other 50% are still plumbing and moving the soil. For those, what we propose is some mechanical procedures to, for example, if they have a layer within the soil which is compacted, to use an implement to break it down. But in general, we are looking more to crop rotation, zero tillage, and eventually, if necessary, any mechanical implement apply.
Okay, thank you. So we have two questions in Spanish from Doriana Fuliada. And as you know, despite being married to a Spanish speaker, my limit of Spanish is around
I know that you can speak in Spanish, okay?
So I'm going to try and say it in Spanish, and then you can tell me what it means. ¿Cómo se vincula huella hídrica y sostenibilidad social?
Well, that is a very nice question, Doriana. What is the link between the social sustainability and water? When we are talking about irrigation areas, it's more complicated because definitely they are organized. For example, in Argentina, they are organized like a small cooperative or small teams, and they are sharing, you know, the amount of water that they are using. So definitely there, we need to work hard in teams of farmers, because definitely that can be a key point. When I can irrigate, when is my time, when is my, how much water I can apply when we are sharing the irrigation channel, no? So definitely that is a good, very good question. For irrigation, we have to definitely work as a cooperative or looking in that way, basically. When we are talking about rain-fed or rainfall conditions, the situation is different because we all depend of the rainfall. We may, probably people just go to a church and pray for more rainfall, but definitely it's not the same strategy when they are talking about rainfall and irrigation systems. But water can be definitely a key point to make the farmers, or to bring the farmers together, which is essential, especially when we're talking about small farmers working as cooperative, that they can share, for example, the harvester machine, the sowing machine, that they can pay together the different taxes or whatever. So yeah, it's linked definitely, and can be a good strategy to link social interaction and water, especially under irrigation.
Okay, thank you. Now I'm going to try the second question, which is even longer, and hopefully the interpreters are interpreting that into English and French. and I apologize to the interpreters in advance of my Spanish. Hay analizado impacto comparativo entre sistemas de producción algodonera convencionales y sistemas agrozoológicos, is that right?
Agroecológicos.
Y biodinámicos.
Yes, perfect. Very nice question. We are working.
What does it mean in English?
What does it mean? If
in English,
we have compared the production, the conventional production, to the agroecological production. I think that is a really interesting process, what's happening today in many countries around the world. This season, we started a project in different sites of the north of the province, but we know also that in another provinces, they've been working already with agroecology systems for many years. So I guess that it's a really good way to understand what's going on with agroecology, because it's all a learning process for us. I think that traditionally, in most of the cotton production systems, the conventional cotton production systems, we've been demanding all the time agrochemicals, insecticides, etc. And we stop being critical and analyzing, for example, the interaction between beneficials, pests, weed, etc. So I think that having this new way of looking the complex interaction within an agroecological system would help us to think about, again, in terms of social, in terms of environment, in terms of productivity. So we are running some experiments in farmers' places, which is really interesting. We are having some information, but I think that it's not worth making a comparison. Why? Because it's completely different philosophy in terms of how to produce. What I believe is that we should try to put that cotton in a special market, for example, adding value at origin, helping to incorporate new communities like indigenous, different small farmers. I think that is an opportunity rather than having or falling in comparison, because definitely yield may not be a good point to comparison. We definitely have to compare, if we compare about sustainability, the three: social, environmental, and production.
Thank you. Marcia Lanfranchi asks where she can find the best graphic visualizations that show how the cotton plant uses water and where are the critical stages by growth stage. I think actually, Keshav, we can send her some of that easily. So Marcia, we'll get that to you very soon. Keshav, have I missed any questions?
Yeah, there's one question from Dr. YG Prasad, Director of Central Institute for Cotton Research, Nagpur, India. His question, Marcelo, is at what critical stage of the crop do you think that there's a need to strike a balance between vegetative stage and reproductive stage using growth regulators? And again, related to that, he's asking, it's very tricky to use a growth regulator in the tropics because of the unpredictable weather conditions and the stress that the crop could probably face.
Great. Both questions, one related to the balance between vegetative and reproductive. We'll know that cutout is our final point where we can do anything much after that, you know. So I do believe that it's good to have a good balance between vegetative and reproductive before that. That's essential. What we can see is that depending on the environment, if we are talking a template or more tropical or subtropical environment, we can play about having more or less vegetative assimilate earlier. if we are having probably a pretty cloudy area where we have like humid environment and we develop a high amount of biomass production earlier, we may have too many abortions later. So, and the opposite around, when we are talking about a more drier place, but with a high amount of solar or light availability, would be ideal probably to have more or enough resources in terms of assimilate earlier in the crop. So I hope that I answered that question.
Yeah.
And the second was related to plant growth regulators.
Yes, what he's asking is the use of plant growth regulators in the tropics is a tricky subject. That's because of the possible stress that may be imposed on the crop due to weathers, due to unpredictable weather. It could be heat, drought, it could be anything.
Yeah, well, that question, we are having that situation all the time here in this part of the world, and we are subtropical, and it's a challenge to apply plant growth regulators. When we are talking about a dry place with irrigation, probably irrigation manage, then as soon as we start having more humidity or more water availability, the problems or the uncertainties increased. So what I would recommend is, if we don't really know much about the distribution of rains, and I can expect huge amount of rains or longer period of drought, I will be paying attention to that, the availability of rainfall actually, and the cloudy weather, because we all know that if we apply a plant growth regulator with that condition, we won't have any effect. So what I would do is to have probably different small doses and follow and monitoring the crop as it goes. Unless I know, for example, that the history of that paddock, that soil, it's high fertility, it has a great previous crop. When everything is almost positive, I will go harder with the plant growth regulators in that environment. So basically, that is what I would recommend.
Yeah, thank you, Marcelo.
Thank you.
Over to you, Kai.
Okay, thank you, Marcelo. There is one last question, which is to be able to share the information, whether we can share the information, and another question about whether the presentations will be available. And yes, we make these presentations available, so you can, if you weren't able to attend the full session, or people missed the session, you can always come back and have a look. So I think that's all the questions now. So with that, I would like to thank once again both our speakers, to Marcelo and Allan, for making this a really interesting and very topical session, and we're really grateful to you. I know Allan's already gone to bed, but we'll write to him and thank him. But thank you, Marcelo, also. So we continue with the next in the series on the Wednesday, the 7th of April, and I hope that you'll be able to attend that. So from me, it's a very big thank you to all of you who were able to attend, and once again to our speakers. Keshav, any last words from you?
Thank you very much, Kai. And thank you, Marcelo. That was a brilliant presentation. We enjoyed it. The issue of water has always been very contentious. And if Allan is listening, he also, he did make a mention about the bias being towards either rain-fed or irrigated. But the fact remains that plants need water. If you're using irrigation water, what is the kind of efficiency that you're introducing into your systems? That would be most important. And my personal feeling has always been that you cannot actually account for, let's say, like for rainwater in the production of a kilogram of lint, because sometimes it's more, sometimes it's less, and nobody has a handle on it. And this is where there was kind of a possible debate and discussion between Allan. We'll reserve it for some other day, but yes, it is the topic of water itself is extremely important, and so is sustainability. And all of us need to address that. Both the speakers, thank you so much. It was such a wonderful day. And for all the listeners today, and all those who participated in this webinar, thank you for supporting the World Cotton Research Conference. We'll meet again on the 7th of April. Thank you so much. Thank you.
I will add something at the end, and please, thank to you for organizing, both of you and the whole ACAC. But I want to make sure that this concept of data information that you produce as organization available around the world is essential. It's essential. That's why all the time I was remarking like how was the information available. I do believe that the work that has been done ACAC for the last many years in terms of statistics, it helps us to understand what's going on and to talk about these three concepts, whether it's true, it's not true, whatever. So congratulations to all of you as well, you know, for making this possible. Thanks.
Thank you.
Thank you, Marcelo. Thank you.
Okay, that is all from us today. We'll see you on in April, on April the 7th, I think it is, isn't it? Thank you very much.
Thank you. Bye.